Hello, thank you for the opportunity to apply for this job. I've built this backend application with using the Spring ecosystem, including Spring Boot, Spring Data JPI, and Hibernate. I also integrated several Maven dependencies for tasks such as CSV parsing, email sending, and database connectivity. The overall backend design is built on this architecture uh, that is consisting of a controller that exposes API endpoints, a service layer that runs the business logic, and a DAO or a repository that handles database operations using JPI. Uh, in this particular project, we Hibernate. The implementation follows a common pattern of using interfaces and their corresponding implementation to promote loose coupling between components. This approach makes it easier to modify existing features or integrate new ones without affecting other parts of the system. Scalability is primarily supported by the database architecture, which is designed to handle large volumes of data and support a wide variety of entities such as shops, brands, and categories. In the README, there is provided the structure of each table and how they are related to each other. Also in the README, it is described the structure of the folders for the implementation for the unit test and integration test. For each feature, the actual query and the filtering for different information is done in a specialized repository class for each feature from the directory DAO features, actual this directory. And let's test each of the features. Let's stop the application. Uh, the application, if the database and the tables does not exist and are not populated, it will create it from scratch. For this purpose, I will drop the database. It was dropped, and let's start from scratch and build the tables and populate them from scratch. The actual initialization is done in this class, and using the CSV files provided. Good. I think the application is up and running and all the tables were populated. To double check this, we received the entries and it seems like everything is good. And now let's test each feature. Before testing features, we also want to say that a requirement for building and running the application is to have on the machine on where we want to run the app, MySQL server running on the port and the desired database and creating it with these credentials. Also, I've written in the README some assumptions, current limitation because I've made because of the limited amount of time, such as the correctness of the data provided in the CSV files. I did not manage to check every corner case that could appear. This is how the application can be downloaded, built, and run from the command line. But instead will use the IntelliJ IDE. Good. The daily shopping basket monitoring feature. For this feature, I will do a post request in this URL, and in the body we add this JSON that specifies the date when we want to go to shopping and the product that we want to buy. Here we receive the response, and after the discounts were made, uh, we can see that the best prices for cafe and latte Zuzu are at Lidl. We can see that the discounts were applied because Basically, the default prices are not with two numbers after dot. Let's continue, and also the response make a total for each store and a total for the whole list of products that we can find in the available shops. And if a product is not present in the database, we do not have information for it, we are notified in the notes section. Let's continue. For each feature, implementation details are provided. This means that there are displayed the controller class, service, and the repository that are used for implementing it, and the product DAO, the product or the DTO, sorry, uh, DTO class that is used for deserializing the information from the request or sending it back. The second feature is the base discount, also a post request needs to be done for this feature, but in the body we just need to add the date where we want to see the base discounts by percentage. Uh, Here the best discount is for spaghetti number 5 that have a percentage of 20, and after for detergent liquid and spaghetti number 5. Let's double check this in the data. It says that Lidl has this discount, and let's see, spaghetti isn't here, maybe in the spaghetti. Here I've found it. It has the discount until 9 of May, and it means that it's also available on the date we requested, and it seems to be good. Let's continue. The third is new discounts, also a post, and followed by the date in the request body. And we received the discounts that started today or yesterday, meaning basically within the last 24 hours. Oh, made a mistake. If we want to double check, let's look on Kaufland discounts. It started on for the lapte Zuzu. It started on 8th of May, and it is in the last 24 hours, and with a discount of 9%. Yes, this is the percentage. Good, let's continue with the next feature. Dynamic price history graphs. For this we will receive an evolution in time of the price. Uh, this evolution is based on the date batches of the product and the discounts that are existing. Let's do it. Get is the type of verb that is needed for this URL. Good. We Here we have two options to filter it by category or by brand. I've filtered by category, and we can see, for example, for these pillows on the 1st of May, it has a price. I think also it benefits from a discount. On the 8th of May, uh, have a new price because I think a new database and a new default price is available for bronze telemea, and the price changes, and also after the discount expires, it will be back to the default price, and depending on each type of product. And the response is built. And if you want to search by brand, let's modify and search by pillows. Here, because we searched and filtered by brand, we receive back the category, and the name of the brand mm, did not appear in the response because it's redundant. And of course, also for this, for bronze telemea, I think it's the same example that we walked through for the category query. The next is feature is best product deals. It's a post, and also we need to put in the body the date for when we want to find the best product deals, uh, and to see which are the which are the best value per unit product. Let's see. This is how the response is received. We receive uh, a list with all the products sorted in ascending order. The best deal, let's say, is for OMA, and the value per unit is 1 and 1 to 5. It differs by type of product. The hygienic is in roll. If we go further, detergent is in liters. For the products that were in milliliters or grams, they were converted in liters or kilogram to be in the main standard, let's say. Good. And the custom price alert. First, I will refresh my Gmail to be sure, and let's execute this post. We want to receive an alert for this product, Cartofi Albi, when the target price will be 2.5 RON or lower. Let's send it. We received an alert that it was saved with success, but the alert will be when the price will be lower than 2.5. Basically, in the database, it is 3.1 RON, and we need to, it has the 45 ID, and we need to lower it manually from this workbench to see that it functions well. I have an error. Can see that. I don't know why it not happened before, but I think we managed to lower the price. And, from time to time, the alert will be sent. Yes, we received it at 5 o'clock p.m. Price alert, Cartofi Albi. Good news, the price for product has dropped to this. I view for the implementation of this feature, I've used a custom method that is scheduled to run every 5 minutes. I've configured it to run every minute. And now I will stop because it is every time it is found that the price has dropped, a new alert is being sent. If we check, okay, uh, these were all the features. For the best practices followed during the development period are modularity, the separation between the different layers in the architecture. I follow the principles of development in Java like KISS, dry, or solid. Also, the architecture was built considering scalability and extensibility for new features and large volumes of data. The project has also consistency in naming and organization of the files, like it is presented in the README, and also using SQL for queries and storing data in specialized tables offers efficiency in storage and execution. By using native SQL queries for each feature to obtain results, we achieve better performance compared to processing data using Java data structures and algorithms. Native queries are often more optimized and reduce the overhead of in-memory processing. And I try to be as concise as possible. This was my project. It was very fun building it, and thank you very much.